HVAC 360, episode number 61. VAV terminal boxes. Hey, welcome back, everybody, to another episode of HVAC 360. I'm your host, Matt Nelson. This week, we're going to be talking about terminal boxes. Specifically, I'm going to go a little bit more into detail about VAV terminal boxes. But we're going to cover the gambit of different types of terminal boxes that there are out there. Talk about their anatomy a little bit, and talk about some tips and hints and tricks about what you're looking at and what you need to do when designing, selecting these boxes, etc., etc. So, all right, but before I dive into all my information, I'd like to point out and thank our sponsor, the Building Commissioning Association. The Building Commissioning Association, if you are a building commissioning authority, that is the place to be, to become a member, to get involved in going to some of the conferences. In fact, they have a conference coming up that if you want more opportunities to network and get more information about the building commissioning, that's a great place to do it. This year it's being held in Denver. It's on May 6th through the 8th in Denver, Colorado. And it's the 21st year that it's been going on. So, if not, if for whatever reason you're listening to this after the fact, it's why don't you catch the one the year after that and plan for it a little bit ahead of time. Again, a lot of things are happening in the spring. The webinar series is going on. If you're listening to this just about the time it comes out, we have one that is on April 17th, so that's just a couple days away. On variable refrigerant flow. So you don't have much time to sign up for that, but you can. There is still time. The next one that's coming up is May 15th. That's titled Is Control Loop Tuning and Night Setback Really That Hard? That sounds like a good one, and that's something that I might, in fact, myself tune into. So, but for more information about the Building Commissioning Association, we certainly appreciate their sponsorship. And for more information about them, go to bcxa.org. That's bcxa.org. Thank you for your sponsorship. All right, so as far as these terminal boxes go, basically, it evolves from the standpoint that variable flow has kind of, become, the industry norm. It didn't used to be that way because we didn't have, controls that we could, that could handle this variability. It used to just be constant volume. So there's a number of boxes that they use to kind of, use through that constant volume system to kind of, make it a little bit variable. But it wasn't truly variable because the fan in the air handling unit still was running at the same speed. Some of those boxes were just, shut-off boxes. They'd use shut-off boxes so they wouldn't overheat or overcool a room. Those were used, basically, they'd have a reverse acting thermostat that made sure that, a room didn't get too hot, too cold. It really couldn't dial up exactly what it wanted, but it could really prevent it from, going too far one way or the other. Then you had bypasses and dump boxes. These, I've seen them in a few cases where they've been used more at a terminal. More often than not, in some of these situations where you have a constant volume air handling unit, you'd have it more as a system bypass. That's where I've seen them more often used. But these bypass boxes they're called sometimes dump boxes. They're kind of like three-way valves for air systems. So instead of supplying, transmitting the air to down the ductwork, it just kind of diverts it out a side port and just kind of dumps it in the plenum space to go back to the air handling unit. So. A lot more times that I've seen those on VAV units, but nowadays with VFD drives becoming more the standard on these rooftop units or small air handling units, these things are becoming more of a thing of the past. Now, if you talked about the deluxe Cadillac system, when you're talking about the, when you're talking about the constant volume system, it was the dual duct. When money was no object, they would put in a heating duct run, and then right next door they'd have a cooling duct run, and it was a constant volume at the dual duct box, and it would just constantly blend this combination of hot and cold air, and it would transmit that to the space at a constant volume. And I mean, you got exactly the temperature that you wanted. It really didn't matter. But obviously the problem is you're kind of simultaneously heating and cooling that air, so that was kind of an issue. And again, you didn't have you just had the same airflow regardless of what temperature you wanted, and you didn't have any savings on the fan horsepower side, whatever, so to speak of. So the one thing that I'll kind of point out on the dual duct box that was kind of a little bit interesting as far as been my experience. I've actually I've used them a couple of times in a replacement situation, but the one thing I find interesting is that you think that a terminal box would have one controller and it would be able to control whatever you want. But in fact, for the dual duct box, it was like they took, two single duct boxes and they slapped them together. So they had a controller on each side, which, frankly, didn't, it not only it made a huge kind of maintenance kind of area where you'd have to have, a couple feet on either side of a box to be able to service it with the control panel, but it made things a little bit more tricky because, you would have one thermostat to a particular, you'd have it to one side or the other, depending on what your dominant side was. And I thought it was kind of strange because in the loss of a building automation system COM failure, when the network went down, sometimes you would have basically whatever side that the thermostat was connected to, that had control. The other side was just wherever you left it, and it was kind of dead in the water, and that's why you put it on. You connected it to the side that was kind of your dominant dominant side as far as need goes. So if you're predominantly a heating region, you'd have it on the heating side, and if you were predominantly in a cooling zone or region, you'd put it on the cooling side. So I thought that was kind of weird that they, you just couldn't make a controller that took care of it all. You just one controller. No, you had to have two controllers. So I don't think much has changed since then. But there again, I haven't necessarily specified a dual duct box in a number of years. So check with your local manufacturers and your reps to get the lowdown on that. So those are pretty much the common constant volume systems. Now, when you get into the variable volume boxes, VAV boxes, you have basically your single duct cooling only box, which is nothing more than a valve in a box. That's pretty about as much as as simple as you can get. You also have, you can kind of, kick it up a notch if you want supplemental heating and cooling, and you can get it with a hot water coil and or electric reheat coil. So those are some of the options that you can get with a single duct VAV box. Now you can get into more of a fan powered box. And the fan-powered box, and sometimes, I've seen it in literature, sometimes referred, you'd have a serial fan-powered box and you'd have a parallel fan-powered box. And I think, just to keep it in mind that the serial fan-powered box, that has constant flow. Now, it's not like a dual duct box where you have constant flow from an air handler, but you have this kind of this makeup air. It'll basically induce air from the plenum, and it'll bring that into the box, and it'll send it out to the space at a constant flow. So sometimes it's referred to a constant flow box. You have a parallel series fan-powered box, and that pulls air. The fan actually pulls air directly from the plenum And so you can kind of take that, that constant plenum air, and sometimes that fan's on, sometimes it's off, sometimes the primary air valve is opened all the way. But it basically has two inlets, but one of those inlets has the fan on it. To kind of reiterate that once again, the series box with constant flow is constant flow because it has a fan on the discharge. So that fan is blowing, and it's actually a larger fan than you'd find in a parallel box because those fans are just sized for the heating load. The series box, that's sized for the whole kit and caboodle. That's your primary air and what have you. So those fans are a little bit bigger on those series powered boxes. The one thing about the series powered boxes, not only does it have the fan on the discharge side, but it will have the fan will always be on. So when the unit's on, the fan's on, which I'll kind of why that's important. I'll kind of make mention of that in a little bit, but as far as adding on supplemental heat like electric reheat and all that hot water heating coil, that's all going to be downstream of the box. So it's going to be on the discharge of the box. So you have the fan blowing in, straight into the electric coil or the hot water coil. Now, as far as the parallel box, this, the fan in the parallel box, again, is on that inlet, that plenum inlet. So it'll cycle on and off based on whether or not you need, any supplemental heating. It'll be like the first stage of supplemental heat. That can be objectionable. When you're sitting in, say, a classroom situation and you have these boxes cycling on and off, it can get a little bit annoying. So a lot of, if you're dealing with an area that's a lot more sensitive, you may want to think about a series-powered box. Even though the fan's bigger and arguably it might be louder, you're going to have a constant noise level, which, A, is easier to attune, and B, is easier to tune out as a person. You really notice when a fan shuts on and off. That's really quite distracting, especially if you're in a teaching situation in a school. Now, both these boxes, or let's just finish it off, the parallel box, as far as where you can put the heating coil, that's a little bit different. The electric coil is still going to be on the discharge side, but the heating coil, you can actually put it on the inlet, the plenum inlet. They'll allow you to do that, and for some manufacturers, that's an approved method. Regardless of either one of these, the series or the parallel, since you're pulling plenum air, you're going to need to filter it. So that is a maintenance headache that you're able to do. Now, why would you use a fan-powered box even to begin with? Well, typically you're going to use a fan-powered box. You're going to use them around the perimeter of a building because you need supplemental heating and cooling. You want to be able to do that when the building's not occupied, and you don't want to necessarily turn on your primary air handling unit. So you don't want to have to light up the whole system just to satisfy a couple of spaces that might have gotten cold or might have gotten too warm. Well, actually, too cold, because it won't help you during the cooling season. So heating, supplemental heating around the perimeter, or if you have a roof condition, that's where you're going to use it there. Typically, if you're going to use a single VAV box, you're going to have it, cooling only. That's going to be, someplace that always needs cooling, doesn't really ever need heating. And you don't have to worry about a minimum there. Or you have a shutoff box, whichever is specified. When you're dealing with areas, and that's one of the things that even I wrestle with. As far as these single zone boxes, obviously, H3-061. They say, hey, you have to have if it's an occupied room, you're going to have a minimum ventilation rate. I've had cases where the room isn't as highly occupied as you would have imagined, and you do get some subcooling, which obviously causes problems. Thermal comfort, really kind of trumps the need for, outside air, because if you can't be in a space to actually use it, then it's pointless to have good indoor air quality. The only other box, actually, I did find a new box that typically I've thought of these as more of hospital units, but they're induction units, and really it's they kind of put it after the fan powered boxes because they use the Venturi effect, and it actually induces the plenum air into the device to mix it there. So those are kind of some of the boxes, and some that are more typically used. Again, the straight single duct boxes and the fan powered boxes. Those are probably more popular boxes that you're going to end up running into and their uses. So, what exactly what's their anatomy? What are they actually constructed of? Well, essentially the body of the box is going to be, it's going to be a sheet metal casing that's kind of square. Sometimes it might be a little bit more rectangular, but typically you're going to have a open end on one side with a that's open to the downstream ductwork, and then on the inlet side you're going to have some sort of reduced diameter round inlet connection. Now that's kind of there's a couple of reasons for that. On the inlet, the whole purpose of having this reduced inlet connection is to increase the velocity. Most cases you want to be able to reduce the velocity, but what's inside those inlets are going to be the airflow measuring station. That's going to be where you're going to measure how much CFM is actually going through the box. So you want to be able to increase that speed, because at low flow, you're going to lose all your accuracy if it's the same size as the box. So you want to be able to increase the speed. Now, having said that, a lot of times you want to make sure that you don't have that same diameter duct on the inlet for too long, because that's going to be an extreme pressure drop for you. You want to be able to transition down to that inlet, and you want to be able to get it through that flow measuring device and through the valve. And on the inlet side of that, those inlet conditions, those are very crucial. You want to be able to have straight duct coming into the airflow measuring station, and that is going to be critical. And it's so many times I've seen it done improperly, where it's practically kinked, and you get the accuracy of the reading and the validity of the reading is nowhere near what it needs to be. There's no way to get an accurate CFM from that inlet connection if you have some sort of kinked or hard 90-degree turn into that inlet. Some engineers are even specify, hey, I'm going to have a hard piece of duct pipe connecting it to that, to make sure that the contractor doesn't try to do one of these Z bends with a piece of flex. But a lot of times the contractors balk at that and don't necessarily put it in, unless push comes to shove and you have them over a barrel and you're really trying to get them to change it out. But most contractors don't want to do that. Another thing on the inlet is that you got to watch for, and I guess this is kind of more of my lessons learned, is that the flow station, this monitoring station, sometimes in different manufacturers have different patterns. Some people have the star pattern, some people have the cross pattern. They basically do the same thing. A couple of things about that: they have 2 ports, high side, low side on the collar itself, on the outside collar. Sometimes when you're putting that flexible connection on, some people will have these zip ties that they're gonna tighten and fix the connect the 2 pieces together, the box and the flexible piece of duct. sometimes you get those plastic pieces kinked in there. So you got to make sure that they're unkinked and they're going to the control box so you get some accurate readings from that. Another thing that I know that happens is a lot of times, when you get a shipment of boxes out into the site, that flow measuring station actually provides a pretty good handle. It's not sharp; it's usually plastic, and the contractors, if they're being lazy, and the boxes aren't all wrapped up, they'll grab those and they'll swing them around by the by those measuring stations, and that can damage them sometimes. So if you're not getting a reading, that might be why you might want to look at that. Other things, other than that, the inlet, the body of it, really you have a valve. In most cases, some cases I guess you do have a straight, round terminal unit, but that's not too common. Typically, they're going to be square, so you're going to have a square damper in there, opening and closing based on what the controls are telling it to do. Sometimes you're going to have a discharge on it with a heating coil. The heating coils, again, the electric coils, they'll have a kind of a larger disconnect panel that kind of goes on the side of it. And the important thing about that is you're going to need the clearance as far as the electrical codes say to have it on the box. Hot water coils, they're going to actually have a hand, whether it's a right hand or a left hand connections. So those are going to be some of the things that you can vary around there. As far as the last piece really is going to be the controls. So the controls are going to be mounted on the side, and again, you need the clearance similar to the electrical panel. You need the clearance to that panel to be able to get in there and monitor that. And again, with the fan powered box, you have the inlet, the fan, and the filter. So those are some of the maintenance items. Typically, when I see them laid out, I prefer them to be, show, you want to show the whatever the connection is. If it's the controls, you want to show the controls panel, and you want to be able to show a dotted line saying, here's the service clearance. At least show that you're thinking about it. It may not necessarily translate real well into the design when it's actually constructed, but at least you've made that attempt and you've planned it out appropriately. So at least the contractor knows, okay, there's supposed to be some maintenance there. When you deal with ceilings, again, and I've talked about this on maintenance access. Realize how far above the ceiling that you're putting these things. They should be, you should be able to reach them over a ladder, or with a ladder without deconstructing the ceiling. And if you locate a VAV box above a hard ceiling, shame on you. You should cross-check your VAV boxes with your reflected ceiling plan that you were supplied by the architects. A couple other things that are interesting. The electric heater. Now, I've had some issues with electric heaters in the past. Obviously great devices, they work well, and they obviously, if you don't have the heating hot water, it's really the only way that you have to go. But you have to be especially careful about flows when you're dealing with the electric heat. The minimum flow is going to be critical. There's no way you can cheat on it, and it's just going to be a tripping hazard if you actually end up cheating on it a little bit. So that's something that you will have to, continually wrestle with if you don't get it right. And again, just be cognizant, talk to your manufacturer's rep, make sure that you have all the minimum flows down for the boxes. Again, when sizing these things, you don't want to be on the razor's edge of size. If it's a smaller box, I would always upsize it one. If you have like a 4-inch inlet or a 5-inch inlet, and you're dealing with a single room, maybe upsize it one, because if you're right on the edge of being able to, supply enough air, especially when you're dealing with maybe like an exterior wall. I would definitely do that. If you have an office on an exterior wall, definitely upsize it one, just so you have that room to work with. Should the load calc be a little bit off, or should you get a little bit more sun, and you can always throw some more air in there. As far as other things go, remember that sizing the minimums, the box minimums. It's easy to say, when you go through your load calculations, it'll spit out a number and saying, okay, here's what you need for heating CFM. But when you actually go to the box manufacturer, they say, well, you know what? You have to go to, instead of if you wanted 100, you have to go for this box size. The minimum flow is 150. There again, you're dealing with that. What's the lowest value that airflow measuring station can handle? So you have to be, cognizant of that. So if there's something that you want because the load calc says, well, you have to make sure that the actual equipment matches up with that. So be cognizant of that. If you want any more information, that's pretty much all I have. So if you want any more information, you can actually go to the Price HVAC website. Price Industries actually has a couple of good manuals. If you make friends with your local Price rep, they have a good manual that you can use, a nice thick book. But they have it online, which is free, and that's a good price. You don't have to hassle anybody. But they have a good. If you want to learn a little bit more about the VAV boxes and the terminal units, some of the things I've been talking about, you can go to the website. I'll put the link in the show notes so you don't have to necessarily worry about that. So, all right, that's it for today. Thank you for taking your time and listening. Again, I appreciate each and every one of you. You are the top 3%, the ever increasing listeners with your penchant for self-discipline and for future further education. Thanks for educating yourself today and choosing HVAC 360 to be your provider of choice. Also, I want to make sure that I thank the Building Commissioning Association for sponsoring this podcast. I would strongly, if you're not going to do anything for the podcast, thank them. Thank them for sponsoring it. Obviously this comes out of my pocket, and I do it because I enjoy sharing my knowledge with you. And but it's nice to be able to share my appreciation with them through you. So if you could, drop them a line. I'll put something on the website so you can show your appreciation. It's relatively easy to do. But I would just ask you to do that. If you like this episode, you want to share it with a friend, go ahead. Be my guest. Please. More people that we get listening to this podcast, the more information that I can get out there. And I want to be able to, kick it up a notch in a couple of different avenues. So look in the future for those. If you have a show suggestion, I'm available and accessible. Matt@buildingx.co. I will get it, and I will respond to you. I always love talking to the listeners. If you want to follow my tweets, Building X is my Twitter handle, and LinkedIn, Matt Nelson PE. If you want to do a not necessarily a friend request, but if you want to link up on LinkedIn. So, with that, I'd like to thank you and get you back to your regular scheduled day. But remember, as always, know what you build and share what you know.